Hello friends and hello student. My name is Ashok Sijala. In this session, we learn the symmetric metric or not in C language. So yes, first I share my laptop screen and here fix the position so you can watch better way my video lecture. And here Turbo C++, I double click and take some process. And now yes is open Alt F file menu. And here we can take our definition, write a program to check, yes, check given matrix is symmetric or not. Okay, so yes, metric is a 2D array, two-dimensional array is also known as a matrix. And metric concept in BCA SAM 2, that is a mathematical and statistical subject, that is metric all of means that sums is there. So here we can say that matrix. So metric is a and metric is 2D square matrix. So 2 by 2 or 3 by 3, and that is a condition of symmetric metric. So first I give one example. What is a symmetric metric? So metric you have to know row and column. That is a we have to any number of row and column, but symmetric metric is a row and column is a same, and you can convert the row into column, and that get the same metric, or that known as a symmetric. So one metric, that it's transport metric, so that is also logic is a transport metric we have to apply. So yes, I give first example that metric is how that symmetric is there. So here that like 1, 2, and 3, that is first row, and then here that 3 by 3 square metric. So here again 2, 4, and 5. Yes, and then here third row. So that is a 3, 5, and 8. So you can watch here our diagonal element is different. So like 1, 4, and 8, that is known as a diagonal element of matrix mathematicals. And here you can convert row to column, that get the same metric, like a palindrome string or palindrome number. You can get the in starting to ending, that get the same number, or madam or Malayalam, that is the same string you have to get. So here our transport metric of that original metric, we can get the same metric. Yes, I first our row and column, that is a same. Yes, that is a first, we can say that. And then again 2, uh, 4, and 5, because that is the same. You can write in row and column. There is no difference. So 3, and 5, and 8. Yes. So yes, look. So here our 1, 2, 3, that is row, and here 1, 2, 3, that is column. Here 2, 4, 5. So here our second column 2, 4, 5, and here third row 3, 5, 8. So here our third column 3, 5, 8. So row and column, that our original metric and the transport of that metric is the same. So that metric is known as a symmetric metric. And otherwise, if your row to column transport metric and that get not same metric, that is not as a symmetric metric. So very simple definition of symmetric metric is a symmetric or not. Here we can check, yes, that program definition. Write a program to check given metric is symmetric or not. Yes, so I think you have to understand. So here any metric that diagonal element is different, and all here 2, and here is 2, here is 3, and here is also 3, here 5, and here 5, then and then we can say that that metric is symmetric, we get. Otherwise that we cannot get. So any metric you can transport, and that in mathematical one symbol like capital A and equal to, yes, I, yes, so that capital A again, and that upon, that is here we cannot, that symbol, and that T means that transport of that metric. So here x raised to T, so Tx I give the new matrix, and that is a symmetric metric. So any metric that is transport and get the same metric row and column means that row convert into row convert into column and get the same element. So that is a symmetric metric. Otherwise, that metric is a not symmetric. So yes, now we can start, and that is a, I give multi-comment line for your reference. That is our paperwork or definition of that. What is a symmetric metric? Now we can apply to our logic. So yes, here my always one technique. First, what is a input? Then what is a process? Yes, our process we have already how to get the symmetric metric. So like my previous video lecture, transport metric, we can apply that same and other comparison of two metrics. That metric is symmetric or not. Like our string palindrome or not, our number we have to check. That type of logic we have to also apply in this session. So yes, header link section std stdio.h, that first header file, standard input output, and then conio console input output. Yes, and then our void main. First I scan one key array, two dimensional array, and here we can take x more 10 by 10, so we can scan row and column. So I j, yes, and then row and column, yes, and one other, that is our transport, so tx, and that also I give the 10 by 10 row and column. So we can square metric, yes, and I first clear the screen, and that I give all number of variable take in declaration part. So here we can enter 2D array rows and column. First we can scan row, number of row, and scan column from user. So you can also use the dynamic array, that is a malloc, calloc, and free, and that the realloc function is there. But in this session we have to not use. So yes, percentage d and percentage d, and then ampersand r and ampersand c. So both we have to scan, and then we can take the message enter 2D array elements, yes, and slash n, and taking two for loop. Just know the 2D array and index start with 0, so I less than 0, I initialize 0, I less than r, and I plus plus, because index start with 0, that is a row. And now second, because 2D array take two for loop and 1D array take one for loop, and multi-dimensional taking more loop. Okay, so here j initialize 0, j less than c column, and j plus plus, and we can index print to our scanning with index. So here x of percentage d, and then percentage d, and column, then I and j. Okay, and then scan a function. So here we can scan percentage d and ampersand x of ij, that is pronunciation x of ij. And here after one row scan, we can provide the slash and new line. So that perfectly, yes. So our scanning part is means input our is ready to two-dimensional array. And now I copy these all, because we have to also print. So I copy and paste. Okay, and here we can change some message and that loop all brace. So here to the array element r, yes, and here no required to brace, because only one statement, so that is a brace is optional. So first we can print, also use the index, yes, here percentage d, and here also remove the brace, yes. So first we can check scan and print with index to the array. So yes, first I save this file. So here we can use the symmetric metric. So metric, and we can say that, or symmetric you can also first use. So dot c metric met and underscore a maximum 8 character we have to provide. So yes, that's save, and let us compile. Yes, and here one blank we have to provide, so not concat our element. So yes, yes, what, yes, here some spelling scanf, yes, in above I think. Okay, so here I type in mistake, so scanf, yes, that not order is perfect means that spelling. So now that ready, yes, let us check. I give 2 by 2. So yes, 1, yes, so 2 and 3 and 4. Yes, so 2 by 2. And here scanf. Yes, so enter. Yes, that perfectly. And here no blank is allowed. Yes, I think. So row and column. Yes, we can scan. And here, yes, that any. So yes, that all are perfectly well. Let us check. So yes, 1 percentage D R and C. Yes, that row and column we have to scan. And here is here R and C, and here is also copy. But let us check that any mistake. So ij and x of ij. Yes. So I compile again. There is no any error, and enter number of row and column. Yes, percentage D, percentage D. Okay, so there is no problem. Yes, let us check. So I give 2 by 2. Okay, now perfectly run. So 1, 2, 3, 4. Yes. So with index, with scan and print. Yes, that is 2D array. And square matrix. Yes, that is a compulsory symmetric matrix. That is a rules you can only apply to the square metric, not odd metric. Means 2 by 3 and 3 by 2. That type of. So square metric must be. And now we can scan to our 3 by 3 means that by 3 by 3 row and column. So yes, that is our 1, 2, 3. Then again 2, 4 and 5, I think. Yes, let us, yes, now perfectly. And then again 3, 5 and 8. Our diagonal element is, so that is a symmetric matrix. But we have to not testing. That means just our print only. So now we can, that is a, we can, yes, you can look our index is also we have to print. So first is row is 0 0 and 0 1 2, and second 1 1 1 second row, and 0 1 2 that column, and third row is 2 2 index and 0 1 2 that column index. That perfectly scanning and printing with index, that is a part is complete. Now I print in metric format. Yes, that now our second goal. So what is a metric format? So that our symbol we can use in our paperwork. So that symbol. And here I remove the index. Yes. So here, yes, I remove this index. So that is the index print. And before after one blank, and here I, yes, now that perfectly. And after the slash, and we can also use that symbol. Yes. So let us take that perfectly or not. Compile, run. So directly I first 2 by 2. So 1, 2, 3, 4. Yes. So that is a metric format we have to print and remove our index. And also take that perfectly 3 by 3 square metric. So 1, 2, 3. I give any element not symmetric. Yes, that perfectly print. So that metric is not symmetric. You can row to column that not get same metric. So yes, now we can check. So first we can copy in row to column in transport, mean TX transport metric. So yes, that is our input part. Yes, that is our input. Yes, that is a input part. So input, and here our output part. So in between we can process, and that is our that is input. And now turn to, so first you can perfectly your input and output, that metric or that type of string programming. Okay, and then in between, yes, here now we can apply to our logic. So yes, I copy this for loop and pass to here first or logic, and that is a condition we have to apply. Yes, if condition, because row and equal to column, then and then we can apply to our matrix means transport and all are these things. Otherwise we cannot take to any logic, means that not any logic. So yes, tx, and here j of I means j of I. Yes, because that is a row to convert column, and here is a same order x of ij. So that is perfectly, yes, that first our logic is transport metric. I same logic, if you not watch my one video, that is a transport of matrix, that logic we have to apply. So here what is ij? That is a same order of x, but here tx transport matrix ji. So first taking the j index and then I. So that convert to the here row and here column, that copy into this matrix. So now we can check. Yes. So again, I copy to our main that for loop, two for loop. Yes. Now second, that is a we have to already copy. Now we can check that both metric is a same or not. So yes, now here what to do? So yes, first we can take one flag variable. Yes. So how? Yes, here I declare flag flag, and here we can initialize if condition. Yes, here enter. That time we can take the flag equal to one, not initially give the one. Otherwise, that giving the message always that metric is symmetric. But when row and column is same, then and then you can flag initialize one. If you initialize here, I just what is saying. So here you can initialize. So that always said that metric is symmetric. But we can check and then give the answer that metric is symmetric or not. So here we can initialization flag to one. So flag 1 means that is a symmetric metric, and flag 0 that not symmetric. So yes, now if condition, and here we can check x of I j not equal to tree transport matrix I and j. That is now we can also convert row to column here gi. Yes, and now we can same order check. So here if not equal to, so that meaning that flag we can initialize 0, and loop is that loop inner loop is break. But that both loop we have to terminate, not only inner loop. So what is a we can done? Yes, here break keyword what to do? Only one loop is break, so that loop is a break. But how this loop we can break? Yes, that is a remaining. So yes, here there are two ways. Yes, first I close this if condition, and here we can give one message also, I think, first, and then we can decide to our if condition. So yes, that metric is uh, metric is invalid. Okay, because that row and column is not same, so metric is invalid for symmetric symmetric, or the metric is or invalid metric invalid for symmetric metric. That type also you can give the message, there is no problem. So here I give invalid symmetric matrix because that is rules is violated, because number of row and column is equal, then and then we can say that that metric is symmetric or not. Okay, and after that in else here we cannot write like here if you I just give the answer. So here like I flag equal to 1, so here we can print like our number is Armstrong or not, or palindrome or not, that type of. So here the matrix is symmetrics. Yes, and else part we can just copy this message. So what happened in outside? So yes, now let us check first. So here metric is not symmetric. Yes, so here we can give, so flag is initialized to here if condition, and if you initialize to here, so that is always give the answer. Here I give initialize 1, so that if condition is always true, and that give the answer that metric is symmetric. And now here what happen if metric is not symmetric or not? So if symmetric, that give perfectly answer, but that after that is a the metric is not symmetric, that give. So here we can give uh, invalid metric, that also give the metric is not symmetric, invalid case, because row and column is not same. So we can take in outside if else, but we can take in here inside the if condition. So let us check both what happened. So yes, here we can also provide slash n. So otherwise that same line is appear. Okay, now what is a solution? Yes, here is remaining. So that if here we can discussion. So break is a only one, that inner loop is break. So that is a rules. Break keyword is only one loop is terminate. So how we can terminate this outer loop? So there are two way. First way I can give. So here that is a, we can say that if all loop is repeated and the flag is not zero, so that is row and column, or we can say that our I and we can say that not equal to j. So that is a not equal to if all root repeated, and if break, then that metric is not symmetric. So here we can also write the break. So that is a first way. So I not equal to j, that type of condition. Okay, so that is a outer. So what is this? This flag is zero, and that loop is inner loop is back, and that if condition outer loop is back. So there are two time we can provide. That is a first way, but that not proper. We can provide two time if. Here we can also take inner if, and here we can take again if. So that not better. So I remove this first way. That is also a possibility. But now what to do? So our flag variable, yes, here we can take the flag. If flag is zero, so here we can in that outer condition and the logical and operator and first flag. So what is that meaning? If flag is one, that positive value, so we can check in if condition. So both are true, then and then that continue loop. Otherwise, is here is a flag is zero and this loop is back. So inner loop. So that loop also automatically that is back because flag is zero. So that condition is false and that loop is terminated. And here our goal is achieved. So that is a perfect logic. Yes. So that is, let us check. And here we can outside and inside. What is different? So I that is a first take outside. We can take in inside the if condition. Yes, that is a better. So let us first I give to first our logic is work or not. Yes. So I give the first 2 by 2 square metric. Yes, and 1 and 2, and what happen here? So you can 1 and 2, that is a, and 3 and 4. Yes, look, the metric is not symmetric and print. Yes, that metric is not symmetric. Yes, so row and column. Yes, that perfect answer. And here one slash and is required. So here that message, yes, here. And now here I give 3 by 3. Yes, so 3 by 3, and that our paperwork. So 1, 2, 3, and then again 2, 4 and 5. Yes, and then 3 and 5 and 8. Yes, that is a symmetric metric. Yes, so metric is a symmetric. Yes, perfect answer. So yes, look here, row and column is same, but here we can print the x because that is a symmetric. Now what to do? Here we can last print the transport of that metric tx, not x, because that is a same, but otherwise not same. So we can take not original metric. Yes. So now let us check. And here I give the some on different order. So I give the 3 row and 2 columns. So that is a not apply to symmetric metric logic. Yes. So invalid matrix and other that also give the metric is not symmetric. But that is the invalid operation, means that not apply because that not square metric. So after that, that giving the metric is not symmetric. That is a proper, but that rules is a violation. So we cannot say that that metric is symmetric or not. So that not proper. Okay. So that is a what to do. So that is a I give one that if condition we cannot take to in outside if I just delete means shift delete, and inside the if condition, yes, here if row and column same, then and then or that print that metric is symmetric or not. So I give all if conditions. So yes, now that perfectly work. So I initially not give, so you can get the idea. So what happened in this session? So yes, now we can take all perfectly. So I save, yes, compile. Now, yes, let us take first perfectly 3 by 3 square metric. So I again give our first paperwork. So 2, 4, and I think 5. Yes, now perfectly. And 3, yes, 3, 5, and 8. Yes. So that is symmetric metric and 2D array element that print the transport metric of that metric. So row converting to the column, and you can get the symmetric metric. Yes, that is a symmetric metric. And now we can last means perfectly our testing. We can take in this if condition if else, yes, row equal to column. So then and then we can give the answer the metric is symmetric or not. And here is a very important to your development logic. So here we can add just how that is second way perfectly we can terminate. So let us take here, give some different row and column. So here 2 and 3. So that is not square matrix. Yes. Yeah, so 2 by 3. So 3 column and 2 row. So 4, 5, 6. So yes, invalid metric, symmetric metric, invalid for symmetric metric, and that your metric. Yes, that not so no any answer not symmetric or not symmetric or symmetric we can take in if condition. So only give your element. Yes, that is your array to the array, and that is element, but that not invalid for symmetric because that is not square metric. Yes, that answer is a because two row and 2 row and 3 column, but must be 3 by 3 or square metric. That is a rules of symmetric metric. So we can apply the all perfect valid, and that is a very interesting logic here. So let us check. I give the here directly. Yes, here you can know that is a just transport metric is applied. So I think you have to understand. So here I control F8 watch window, and if you know very well, I think all my number programming or so many video lecture I apply the watch window. So alter W, and here is our watch. Yes, and alter W again and our output. So here we can set yes green span and enter, and here our X of ij. Okay, and here our TXI and J. Yes, how that giving the answer not symmetric or metric. And here our flag variable. So that is a initially one, and yes, that now I think all are perfectly well. So let us check here directly. We can start here. I think you have to understand. So I just pass out. So yes, I run. Yes, but here I take that size is some decrease. So that perfectly. Yes. Now control F9. Yes. First I control yes and give the symmetric metric. So 3 by 3. Yes. So all are perfectly. So let us take. So yes, 1, 2, 3, and then 2, 4, and 2, 4, and I think 5. Yes, that 5, and then 3, 5, and 8. Yes. So here we start our comparison, and here both condition is satisfied. So here you can also take like I and then J. Yes, and then here but some size is yes here first I decrease that size and increase this watch window size, so we can take one variable more. So that is not sufficient. Okay, we can take the flag variable is already there. Yes, I think no need. Yes, let us check. Yes, all are valid. Yes, so that is, and also output window we can take here. Okay, and that size is increased so you can watch better, right? So all are our element is there, that is metric is symmetric. So let us I alter R, so that is a trace into trace F7 function key. So yes, I is 0 and J is 0, and yes, first our that is not equal to, but both are equal to. So if condition is false, again that 2 element, so that is the same. Yes, 3 3, and now that is I plus plus. So I is a 1 and J initialize 0, so that is 2 2. Yes, that 4. Yes, 5. Yes, now again I plus plus, so that is a now again J 0. Yes, that is a uh, means that third row. Yes, that same element. Yes, now that perfectly flag is directly 1. Yes, here is a 1, so that is a symmetry. And now turn to print. Yes, that already perfect print. Yes, look in our output window. So I just pass out because that is a print only element. Yes, and now last testing, that is a symmetric. We have to not if condition is always not equal to, and now I again because we cannot symmetric. So then what happen and how to loop is terminate. So I give the like 2 by 2 square metric. but not give the symmetric means order. So I 2, 3, 1, 2, 3, 4. Yes. So from so here you look first is a I press F7, so I is 0, and here that element is yes 1 1. Yes, that perfectly not equal means that not equal to but equal to. So condition is false. Now here is loop. So here that is 2 and here is a 3, because you can look in our element in output window. I just press here just because that press F6 function key. So yes, now cursor is here. That is shortcut key, F function key. You can move one window to other. So here that is comparison. I is a 0 and j is 1. So here I is a 1 and j is a I is a 0 and j is a 1. So here is a 2 and then that is a t. Yes, that comparison ij and transport matrix. So that is a not same, because here our that is a here is a 2 and here is a 3 element. So yes, here is a 2 and here is a 3 element. Why? Because you can look in the picture. So I is a 0. Yes, so 0 is a and 0 and j is 1. So 0 and 1. So 0 and 1 is a 2. And then again that comparison that I and j that is not equal, but that yes, that condition is true, not equal, but that is not equal, because that symmetric, so that is equal but that not equal. So both are metric is different. That is a our original metric and that is a transport metric. We can already take row to here is a row and column, and here column and row we can already take, but that not also that symmetric. That is a same element 2 2, but here not. So what to do? So here if condition is true, yes, that not equal to but true, yes, and flag is 0 initialized. So flag is 0, so that is a break one. If for loop is break, here one terminate in inner loop. And how the after? So yes, that directly take to outside. Why? Because flag is a here that and logical and operator. So flag is 0, so automatically that and operator both condition. This loop means I less than r, because r is a I think we have to apply to 2 2 by 2 square matrix. Yes, perfectly. So that condition is true because I is 1 and R is 2. That condition is true, but flag is 0. So that flag, that 1 is a positive and 0 is negative. So not logical and operator is applied to this condition. Directly come out to uh, outer of loop. So inner loop is also false, and flag is a not 1 but that 0. So look in the watch window. Yes. So that metric is not, and then that is not invalid, but 2 by 2, but that element is a not our row to column. That symmetric convert row to column, and yes, that element is print perfectly 1 uh, 3 and 1 2. Now that column and that look, or that is not symmetric, because we can row 1 and 2, that is our column 1 and 2 and 3, and that is a not same, means that symmetric order. So yes, I think that perfectly the metric is not symmetric. Yes, and same if invalid, that is just bypass. Yes, last testing in watch window. So again, I control F9. Yes, control F9 and 2 by 3. Yes, that directly condition terminate if condition. Let us check. So yes, 3 by 2 by 3. So yes, that invalid directly matrix, but we have to not here. We can just remove this all. So here, just our, because that condition is directly false. So our watch window is not applied, because here that directly condition is terminated. So I control F8. So you can remove this watch because not required. So here our if condition is directly false. So that is a come to else part and print that message invalid metric, and all that element is print. So very simple. So no required to watch window. We can also say that that perfectly valid, because row and equal, then and then we can apply this all logic. That is very, we can apply the math rules of symmetric matrix in our logic part. Okay. So yes, I perfectly give the idea what is a symmetric metric or not, and here we can apply the maths rules also in our logic. So yes, that is our input now, and that is a logic we have to develop to ourselves. So very simple and very important logic. And here is a very interesting for your knowledge that condition we have to apply. So very best way we have to apply flag. Yes, otherwise you can take one if condition to here. I previously said. So here we not take any if condition, directly AND operator, and here flag if zero, then condition is the outer loop is also false, and then directly say that that is not symmetric. Okay, so now yes, I complete my session, my part of this session, and write this program to see notes if you prepare. So here very important logic for your knowledge. 2D array to symmetric metric. So 2D array known as a matrix array. Okay, so now I close this session. So yes, I control F3 function key. Yes, watch output and message and control X quit. So yes, subscribe my channel Ashok Sijal Academy. Press the bell icon to never miss any update. Thanks for your watching, supporting, and sharing my video lecture. And any doubt of this symmetric metric definition, to write in comment section, or any other concept in C or any other language. So thanks again, and Hare Krishna.